Hey, my name's Nick, and we're about to learn about piezoelectrics, but first a little bit of history. In 1880, the Curry brothers were the first to discover the piezoelectric effect, but it wasn't until a year later that the converse effect was discovered by Gabriel Lippmann. In World War I, we saw the first commercial application when it was used in French submarines as sonar. In World War II, they made research advancements and made synthetic materials called ferroelectrics that produced the piezo effect. Today, piezos are used in TV, sensors, buzzers, and radios. Now, let's look at what's going on inside piezos. Looking at figure 1 here, kind of zoom in on the molecular structure, you see that the orientation of the molecules is random. This causes the net charge density to be 0 and no dipole moments to occur. If I can bring it over to figure 2 now, we have pressure being applied to the crystal, which means that the net charge density is now something besides 0. And when the net charge density is something other than 0, dipole moments are occurring, which means that electric field is being induced. So to test this effect, we took a piezo out of a fire detector and we hooked it up to Logger Pro via those wires and then hooked it up to the computer, and this will measure the voltage output coming from the piezo. This effect will be tested 2 ways in order to figure out more about the voltage output. The first way is being demonstrated now, which is continuous tapping on the piezo. We will compare the tapping output to that of a press, hold, and release, which is being demonstrated now. So here we're just tapping. It's pretty clear that we have an oscillation going on. Voltage peaks and then it comes back down and goes negative. So we're going to compare this to see what a press and release is going to look like. So here we have press and release. Press, hold, release. Press, hold, release. One more time. So it's pretty clear that it peaks when we press it down, and then when we release it we get a negative peak. So if you know anything about a current, you can imagine it as a tube filled with balls, and when you press it, when we apply stress to the piezo, we get a current going through. We're pressing down, so it distorts the molecular structure and it causes the electrons to be funneling through. So when we hold it there, the electrons aren't moving, nothing's going on. And then when we release it, we can imagine the current is being sucked back through the other way, which is why we have a negative current. I hope you enjoyed the video, and we'll see you next time.